Hello, in this tutorial series we'll be going over how to take a SolidWorks model and bring it into Gazebo using our SolidWorks to Gazebo exporter. A download link to the exporter, as well as a link to the documentation, can be found in the video description. Once you've installed the exporter, the first thing you want to do is make sure the exporter is enabled. You can do this by going up to Add-ins and making sure this checkbox here is checked. You're going to want to make sure you do this before you launch or open any document that you want to export. If you want to enable the plugin to launch on startup, you can also check this box and it will launch as soon as you open SolidWorks. Once you've done that, we can now open our model. For this example, we'll be using our GearsBot model, which is one of the demo robots we use a lot for demonstrations and teaching. So you'll notice up on the top ribbon, we have a new tab called Gazebo, and there's 3 buttons here. This is what you'll use to do all of the configuration as well as the export of your robot. The first button is exporter settings. These are settings that will be applied across all models, and there's a couple things here. The main one is to enable or disable the FRC sim components. If you are not using this exporter to go along with the FRC sim plugin for Gazebo, then you can disable this and it will disable those features. This will be on by default. You should also leave the debug mode disabled, as enabling it will disable many of the safety features in the plugin. The main button you'll be using is this Manage Robot button. When you click on it, it will open up this window, and there's 3 separate parts to this. Right here we have the robot graph panel. This will show a graphical representation of the robot's links and joints and how they connect. Down below we have a panel for adding new links as well as adding motors and sensors of various type. And on the right we have a property manager that will let you edit the properties of whatever item you have selected. You can click on different parts in the panel and it will switch here and let you edit those parts. The final button on the panel is the export button. Once you finish configuring, you can click on this button. It'll run through a series of steps to verify the model is valid for export and then export it. We will go over this a bit more later on. The first thing you're going to want to do to configure your model for export is to set its orientation and the origin point. So to do that, we're going to open the Manage Robot window and make sure we're not selected on anything so that we're in the Robot tab. We can set a name for the robot. It'll default to the name of the model, but you can set whatever you want. In this case, we have Demo Robot. So then we will click this Select Model Origin button and a page will open up over here. So we can start by selecting the origin point. This should be about the center of the model. The base plane is where the ground plane will be once you bring it into Gazebo. So it should be like approximately tangent with the wheels, like this plane is. And then the direction axis is the axis that the robot should be facing. So in this case, we have the front, which means it's going along this line here. So we'll just select some edge or line that's in that direction, like this one. You'll notice this triad appears showing the origin and the direction of the robot, with the z-axis going up, x-axis going back, and so on. You'll notice the x-axis is pointing in the opposite direction that we want the front to be facing on this robot. So we can just click this button and it'll flip around and we now have an origin point. So we can just hit the check mark and be done. You can also set the exporter to include a FRC field when you export the robot, and this will be included when you launch the world file in Gazebo. You can set it to be either 2014 or the 2015 field as of right now. Once we have the model origin set, we can now work on defining the layout of the robot. So the way Gazebo works is what are called links and joints. A link is a group of parts and components that are all stuck together so they do not move relative to each other. These links are then connected by joints, which allow for specific types of motion, and there are different types of joints for different types of motions. So if we look at this robot here, it's got a base link, which would be the chassis with all these like parts here. They don't move relative to each other, so they're all one link. Connected to that chassis are the wheels. So the wheel would be a link, the chassis would be a link, and those 2 links would be connected by a joint. Also connected to the chassis is this elevator carriage. This elevator carriage would be its own link and be connected to the chassis. Following the elevator carriage, we then have a wrist. This wrist is connected to the elevator carriage, so those 2 would be connected by a joint. And then we have the claws, which would then be connected to the wrist by more joints. So now that we understand how this thing is laid out, we can start setting it up in this window. So first we're going to add a sublink. This will be the elevator, so we can just label it and label the chassis as well. You'll notice that a joint appeared between the two links, and we'll talk more about these in a bit. So under the elevator, we have a wrist link, and then connected to that wrist, we then have the two claws. So the left claw and the right claw. So this is the elevator setup. It goes chassis, elevator, wrist, and then the two claws. So next we have the wheels. So we'll just add 4 wheels. And I'll just resize this. And then we can just set them to their names. In order to make this more readable, we can also set a color for each link. So let's say we want the chassis to be green, the elevator to be some other color, like say blue, and so on. And this can just make it easier to read the thing because they're all different colors. So now that we got all the links set up, we can now set the types of joints between them. So for the elevator, it's connected by a linear joint as it moves linearly up and down this path. So that's correct to start with. For the wheels, we're going to want a joint that rotates because they're a wheel. So to do that, we click on the joint, and then we click on the joint type thing here and a drop down. So here are the different kinds of joints. There's 7 of them. The first is the linear joint, which, as I said before, is basically a joint that just will move along a single axis. Next, we have a rotational joint, which is like a wheel. It rotates about an axis. Following that, we have the screw joint. This is similar to a linear joint, but instead of just moving along an axis, it also will rotate, and the rotation and the movement are linked together by a thread pitch. A gearbox joint is the same as a rotational joint, except it links to a second rotational joint, and those two joints will rotate together based on a gear ratio. A 2-axis rotational joint is like a rotational joint, except instead of being a single axis, there are 2 axes it can rotate about, and those axes intersect at a point, and they are not parallel. A universal joint is like a 2-axis rotational joint, except the both axes are perpendicular to each other. And finally, a ball joint is a joint where the link rotates about a single point and has 3 degrees of freedom. So for the wheels, we're going to want rotational joints for all of them. We will talk more about the properties that each of these joints have and how to set them later on. So the wrist is also rotational, and then these claws are going to be both rotational. And we'll talk about how to link them together later on as well. So there we go. That is the layout of our robot. You'll note that we haven't actually set what parts go into each link, which we will do in the next step. But we now have the layout, so it should be fairly easy to set that up. One thing to note is that if you have a loop of links and joints, like say in a 4-bar linkage, you can connect them together. So to demonstrate this, we will create some more links. So these two will be the first link of a 4-bar, 1, and the second link. So these are the first 2 links of the 4-bar. So now, the next thing we're going to want to do is add another link under here. And so this will be the third link. And now we want to connect number 2 to number 3. So you'll see we have a 4-bar linkage now. If you want to remove a joint, you can select on the joint, whichever one you feel like, and hit Remove Joint, and it'll remove it. And you can do the same with a link. Note that if you have a link that is the only parent to another link, it'll remove all the children. So in this case, deleting 4-bar 1 also removed 4-bar 3.